Good morning students, good morning to all of you. So this is unit 1, conic sections. Topic name is conic section. This is class 5. So today in this class we are going to discuss about conic sections. So in this class we are going to discuss about these topics. They are common engineering curves or curves used in engineering practice. Second topic is conic sections like circle, ellipse, parabola, hyperbola, etc. These are called conic sections. Next, third topic is conic. Fourth topic is general diagram of ellipse, parabola, hyperbola. General diagram of ellipse, parabola, hyperbola. Next, last topic is practical application of practical application of ellipse, parabola, hyperbola. Practical application of ellipse, parabola, hyperbola. Practical application of ellipse, parabola, hyperbola. So these are the topics we are going to discuss in this class. So let us see first topic, common engineering curves. So what are the common engineering curves? So what are the common engineering curves or curves used in engineering practice? So what are the curves generally we use for engineering practice or design practice? So there are conic sections, cycloids, involutes, helix and spirals. So generally these curves are called common engineering curves. Once again listen. So what are the common engineering curves? What are the common engineering curves? Conic sections, cycloids, involutes, helix and spirals. So these are called common engineering curves. So these curves are generally used for design practice. These curves means conic sections, cycloids, involutes, ellipses and spirals. So these curves are generally we use in the design practice. These are the common engineering curves. Next, conic sections. Conic sections. So what are the conic sections? Depending upon the position of the cutting plane, we have four types of conic section. They are number 1, circle, ellipse, parabola, hyperbola. So these are called the conic sections. Circle, ellipse, parabola, hyperbola. These are called conic sections. So let us see one by one. What is circle? What is ellipse? What is parabola? What is hyperbola? So how can we get the circle? How can we get the ellipse? How can we get the parabola, hyperbola? So let us see one by one. So once again listen. Conic section. These are called the conic sections. So how can we get these conic section means? So depending upon the position of the cutting plane. So we have four types of conic section. They are these. Okay. So depending upon the cutting plane means if we cut the right circle cone, with the help of cutting plane, if the cutting plane name is AA, if we cut the right circular cone with the help of cutting plane, then the cutting plane should be perpendicular to axis of the right circular cone. Then the obtained shape is called circle. Once again listen. So how can we get the circle? Circle means if we cut the right circular cone with the help of cutting plane AA, when the cutting plane is perpendicular to axis of the cone, then the obtained section is called circle. See, this is the right circular cone. This is a vertex point. This one is axis. So this is one generator. This is another generator. So this is the height of the right circular cone, and this one is base. So If we cut this right circular cone with the help of cutting plane, so that cutting plane name is what? AA cutting plane. If we cut the right circular cone with the help of cutting plane, AA cutting plane, when the cutting plane is perpendicular to axis of the right circular cone. See here, this is the axis. So here, this is AA is nothing but cutting plane. So this cutting plane is perpendicular to this cutting plane is perpendicular to axis of the right circular cone. Axis of the right circular cone. So if we cut the right circular cone with the help of cutting plane, when the cutting plane is perpendicular to axis, we get the circular shape like this. This is a circular shape. So if you remove the top portion of the cone, so it will appear like this. So this shape is called circle. Okay, I hope you understand. And second one, what is the second conic section? What is the second conic section? Second conic section is what? Ellipse. So this is a right circular cone. So this is a cutting plane. So we are cutting the right circular cone perpendicular to axis of the right circular cone. Then we get the circular shape. And second conic section is what? Ellipse. So how can we get the ellipse? So if we cut so this is a right circular cone. If we cut the right circular cone with the help of cutting plane, BB, when the cutting plane is inclined to axis of the right circular cone, then the obtained section is called ellipse. So for ellipse, eccentricity value it should be less than 1. Once again listen, how can we get the elliptical shape? Means if we cut the right circular cone with the help of cutting plane, this is cutting plane, BB cutting plane. So this cutting plane should be inclined to axis of the right circular cone. This cutting plane should be inclined to axis of the right circular cone. So if we remove the top portion of this top portion, so it will appear like this. This is the elliptical shape. I hope you understand. So see, so this is a right circular cone. So this is a cutting plane. So cutting plane representation this is. So this cutting plane is inclined to axis of the, this is the axis of the right circular cone, inclined to axis of the right circular cone. So if we remove this top portion, we can get the one shape, that is ellipse. Next conic section, parabola. Next conic section is what? Parabola. So how can we get the parabola shape? If we cut the right circle cone with the help of cutting plane, that is CC, when the cutting plane is parallel to one of its generator. So here the cutting plane should be parallel to one of its generator. Then the obtained section is called parabola shape. So this is about parabola. Once again listen, how can we get the parabola shape? If we cut the right circular cone, this is a right circular cone. If we cut this right circular cone with the help of CC cutting plane, so here the cutting plane should be parallel to one of its generator. So whatever the section we obtain, that section is called parabola shape. This is parabola shape. So here this is a cutting plane. So this cutting plane is parallel to, this is generator. So cutting plane should be parallel to generator. If we cut the right circular cone with the help of cutting plane, when the cutting plane is parallel to one of its generator, then the obtained section is called parabola shape. This is the parabola shape. Next, last conic section, that is what? Hyperbola. So how can we get the hyperbola? Means if we cut the right circular cone, one of it with the help of cutting plane DD, if we cut the right circular cone with the help of Cutting plane DD when the cutting plane makes the smaller angle with axis of the right circle cone. Then the obtained section is called what? Hyperbola. For hyperbola, eccentricity value should be greater than 1. This is a right circular cone. So if we cut this right circular cone with the help of cutting plane DD, so this is a DD cutting plane. This is a DD cutting plane. So this cutting plane makes a smaller angle with the axis of the right circular cone. Then the obtained section is called hyperbola shape. This is the hyperbola shape. So these are called the conic sections. Next topic is a conic. So what is conic? Next topic is what? Next topic is conic. So what is conic? How can we define as conic? So conic is defined as the locus of point moving in a plane such that the ratio of its distance from the fixed point to fixed straight line. Fixed point to fixed straight line always constant. Once again listen, what is the definition of the conic? A conic is defined as it is the locus of a point moving in a plane such that the ratio of distance from the fixed point to, so this is a fixed point, so the ratio of the distance from fixed point to fixed straight line, this is a fixed straight line, so always constant, so that is called conic. So here this is a conic, this is conic. So fixed point is called, this is a fixed point, F is the fixed point, so fixed point is called focus, fixed point is called focus, and fixed straight line is called, this is a fixed straight line, so fixed straight line is called directrix, fixed straight line is called directrix. So how can we define the eccentricity? How can we define eccentricity? It is the ratio of distance of the point from the focus to distance of the point from the directrix, distance of the point from the focus, so from this distance to, so distance of the point from the focus point, this distance, the ratio of this distance divided by this one means PF divided by PM, we called it as eccentricity. So that is what, once again listen, the ratio of distance of the point from the focus point to distance of the point from the directrix, this is a directrix, is called eccentricity. Eccentricity is denoted by small e, and this is about conic. Conic is nothing but what? This is a conic. Conic is nothing but curve. This is a curve. Next, general diagrams for the ellipse, parabola, hyperbola. General diagram of ellipse, parabola, hyperbola. So this is a general diagram. This is an elliptical shape. This is a focus point of the ellipse. So this one is vertex point and this one also vertex point. For ellipse we have two vertex points, vertex point 1 and vertex point 2, and for ellipse we will have two focus points. This is focus point 1 and this one is focus point 2. And similarly this is a parabola shape. For parabola shape we have a vertex point, this one is vertex point and this one is focus point. This is a hyperbola, this is a vertex point and this one is focus point. So this is a vertex. So what is vertex? Vertex is nothing but the conic where cuts its axis, that is called vertex point. The point where the axis cuts the conic, that is called vertex point. So this is the general diagram of the ellipse, parabola, hyperbola. Okay, I hope you understand. Next, practical applications of the ellipse. Okay, next topic, practical application of ellipse, parabola, hyperbola. So let us see first one, practical applications of ellipse. So engineering applications of ellipse. So the elliptical shape is used in the construction of dams, manholes, arches, gates, and water tanks, etc. So these are the practical applications. So this elliptical shape is used in the construction of, dams, in the construction of manholes, in the construction of arches, in the construction of gates, in the construction of water tanks, or etc. So these are the practical applications of the elliptical shape. These are the practical applications of the ellipse. See here, dams. So this is dam. In the construction of dam, generally we use elliptical shape, semi-elliptical shape. Next, gates. In the manufacturing of gates, so these are the elliptical gears, gear 1 and gear 2. So in the manufacturing of elliptical gears, so this is we used. Next, tanks, water tanks, arches. So this is a natural arch. So in the construction of manholes, this is manhole. So it will be in the elliptical shape. And the arches, so this is a semi-elliptical shape. Next to ellipse arch. So these are the some of the applications of elliptical shape. This is also a dam, semi-elliptical shape. Next, practical applications of parabola. Practical applications of parabola. So the parabola shape is used in the construction of light reflectors, sound reflectors, and arches, bridges, etc. So these are the practical applications of the parabola shape. Okay, these are the practical applications of the parabola. So generally the parabola shape is used in the construction of bridges. So like so this is a bridge. See, this is a bridge parabola shape. And in the construction of light reflectors, in the construction of light reflectors, these are the lights. In the construction of light reflectors and bridges, in the construction of bridges, so this is a parabola shape bridge. So these are the lights. So this is in the parabola shape. So this is in the parabola shape. Next, practical applications of parabola, light reflectors. So these are the light reflectors. Already we have seen bike dooms. Okay, so these are the light reflectors, so which is in the parabola shape. Next, bridges. This is a parabolic supporting cable. Okay, next to sound reflectors. So this is a hooper. Okay, this is also in the parabola shape. Okay, so these are the practical applications of the parabola. Next, we will see the practical applications of the hyperbola. Practical applications of hyperbola. Hyperbola shape is used in the design of cooling towers, hydraulic channels, and electric transmitters, receivers like radar antenna. So electric transmitter and receivers like radar antenna. So see cooling towers first. So this is a cooling tower. So generally we see in the KTPS, Kottagudam Thermal Power Station, and VTPS, Vijayawada Thermal Power Station. So you will see, we see in the KTPS thermal power plant. And this is also cooling tower. So top portion of the cooling tower so will be in the hyperbola shape. Next, hydraulic channels. Hydraulic channels. So this is a canal or channel, whatever it is. So hydraulic channels. So this is also hyperbolic shape. Next, radar antenna. This is a radar antenna. Okay. So these are the practical applications of the ellipse, parabola, hyperbola. I hope you understand. Thank you. Thank you so much.